Good morning, scholars. Welcome back to the Kemet Maasai Academy channel. Today we're going to look at reflection. Now, what is a reflection? A reflection is when you have an original object, so the original shape, whether it's a line, a point, any object at all, and where it's like you're looking at yourself in a mirror. So what you're seeing is a reflection. Whatever is on one side of the mirror is reflected on the other side of the mirror. So when we're doing reflections in mathematics, we have what is called a line of symmetry, and this line is like the mirror line. So whatever is on one side, whatever is on the left or the right, is reflected on the other side, just like this line was a mirror that you're looking into. So objects under reflection become images. So the new shape that is formed on the other side of the line of symmetry is called the image. It's like when you look at yourself in a mirror, you see your image, you see a reflection of yourself. Now there are properties of a reflection. So let's read. It says objects may be reflected through a mirror line, or a line of symmetry. The new drawing is called the image. In a reflection, the image is the reverse of the objects. Points and lines are the opposite way around. The object and image are the same distance from the line of symmetry. So the original drawing or the original thing is called the object. When it is reflected through the line of symmetry or the mirror line, it is called the image. And whatever the properties of the object, if it was oriented to the left, the image is oriented to the right. If a line was turned up, well, for up and down they remain the same, but left and right are reversed. And the size of the image is retained, so whatever size the object was, the image is the same size, right? So the left and right orientation changes, the size remains the same. Up and down remain the same. So there's no distortion in terms of stretching the object in any way. And whatever the distance is that the object had from the mirror line, the image must have that same distance from the mirror line. So we're going to be drawing the images of these objects that we have on the board, right? For some of them we have a grid that we're going to use. For the others, we're just going to estimate the distance and try our best to maintain that same distance from the mirror line to get our image, right? And we're going to pay attention to the fact that if it is oriented to the left, it must be oriented to the right in the image. If it's oriented to the right in the object, it must be oriented to the left. Alright, so let's look then. So we're going to use, so here we have a triangle. It's a right angle triangle and it's oriented to the right. We're going to use this line as our mirror line. So this is our line of symmetry. Right? We're going to reflect this triangle over here. Now we look at the 3 key points of the triangle because that's what we're going to use to draw our image. This is one box from the mirror line, so in the image it must be one box away. Right? This point is 1, 2, 3 boxes from the mirror line, so it should be 1, 2, 3 boxes. This is 2 boxes up and also 3 boxes away, so we get the same distance, and then we're going to just connect the dots and shape. So once we maintain the same distance away from the mirror line and maintain the size of the object. So 2 boxes up, 2 boxes up, right? 2 boxes across, 2 boxes across. So that is our reflection. This is the mirror line, this is our object, this is the image, and the image is oriented to the left. So the object was oriented to the right, the image is oriented to the left. Alright, let's reflect this object along this mirror line here. So this is our line of symmetry, our mirror line. So we're going to reflect it. So for these 2 top boxes, they are 2 spaces away, so we need to maintain 2 spaces away. So these are our 2 top boxes. These ones, 1 space away, so that's 1 space away, and there are 3 boxes there. And then we have 1 box below. So that is a reflection, that's the image. See, they are both, whatever was up is still up, whatever was down is still down, right? When it's reflected along the vertical line of symmetry, right? If it had been the horizontal line of symmetry, then up and down would change as well. And we're going to do some horizontal lines of symmetry to show that. So what is up will be down and so on. For the vertical line of symmetry, up and down remain the same, but left and right orientation are reversed. Alright, so here again we're going to use this as our mirror line. We're going to try to retain the integrity of the shape in terms of size and distance away from the mirror line. So for all these 4 boxes, they are 1 space. This is 1 space away from the mirror line, so we retain that 1 space for those 4 boxes. Alright, and then we have halfway there, halfway there, and halfway there. So you notice the orientation is going to change. In the object was oriented to the left. See that? It's turned to the left. In the image, it's oriented to the right. Now these are under vertical symmetry. The line of symmetry, the mirror line, is a straight line going down. So when we reflect it, the orientation left to right changes. So now we don't have a grid to work with, but we're going to use our skill in estimation and judgment and try to maintain the same distance apart. Alright, so we'll try to get the same distance there. Alright, and this is the height of that line there. So using our judgment, we try to get, and the length stops there. Alright, so we did our best. That is our reflection. This is the mirror line. That's our object. This is our image. Same distance apart from the mirror line. We tried to maintain that. Now we're going to reflect the letter F along a vertical line of symmetry, vertical mirror line, trying to maintain the same distance. So roughly same distance for the points on the F, there. Trying to maintain that same distance. Down to about there. Okay, so again you notice same distance from the mirror line, the object and the image same distance away. This was 2 centimeters, that's 2. If this was 5 centimeters from here to the mirror line, from here to the mirror line should be 5. Excuse me. Alright, so you notice this F is oriented to the right, the object is oriented to the right, the F in the image is oriented to the left. Let's do it for the E. The original E, the object E, is oriented to the right, to the left. So now, in our image, let's have the same distance apart, so it's roughly there. Same length. So we're estimating using our judgment. How is that? Using our judgment, we see. So this is our object. This is our image under a reflection through a vertical line of symmetry. So let's look at some horizontal lines of symmetry. In these ones, top and bottom will reverse. What's on the top will be on the bottom. So we're going to reflect the U. Okay, so it's going to curve like that. So you notice in the object, it's turned like a regular U. In the image, it's turned upside down. This is an upside down U. The open end, the curve open here is to the top, and the open curve here turns to the bottom. For the W, same thing. It's going to actually look like, well, we need to get that same distance from the mirror line. Maintain that same distance from the mirror line. We're estimating what we're trying to get the same distance from here to here, here to here. Okay? But you notice this is a W and this looks like an M. So the W and the M are really reflections of each other through a horizontal line of symmetry, a horizontal mirror line. How would we reflect this? So keeping the same distance away from the mirror line. And there we go. So what was up is now turned down through the horizontal line of symmetry. Same thing here. So we're going to go that way. There we have it. Now you notice this mirror line is exactly, the objects and the image are exactly on the mirror line for this. There is no space between the object and the image, and sometimes that happens. Like if you were to go right up to the mirror, or if you were to put your finger and touch your image, so there would be no space between the finger and its image. So this is like what's happening here. The object is right up to the line of symmetry, right up to the mirror line, and it is reflected on the other side. There is no space between the object and the image. Same thing for these two. They are exactly on the mirror line. So let's reflect them. And these now, we're back to the vertical mirror line. Trying to get it as close as we can. So that's it. So it's as if we had one big shape and we cut it exactly in two. Same thing on either sides, right? It's as if the original shape was this beautiful leaf, and we're able to cut it straight down exactly into 2 halves. Alright, let's see what we'll create here. Same distance away. Okay, how's that? Maybe I drew the legs too thick on this side. Need to be a little thinner. Alright, but we're estimating, right? And if we had the grid, like if you have graph paper, you're able to do it more accurately. If you have a grid, you're actually able to count your boxes so you can be more accurate. So we're estimating here, but that's the general idea. We try to maintain the same distance on both sides of the mirror line. If it comes all the way up to the mirror line, then there's no space between the object and the image. Just that line between them. It's as if you're right. You know, sometimes you look at a lake, for example, and you will see the land that's right at the edge of the lake reflected directly below the lake. It's almost as if they're touching. Just as when you look at the horizon, you're at the beach and you look at the horizon and you will see the reflection of the clouds or the birds or whatever straight into the water at the banks of a river, for example. Alright, so there will be no space. When there is a space, you have to maintain the same distance from the mirror line. The object and the image must have the same distance. So that's it for reflection. If you have benefited from this video, just drop me a line in the comments to say thank you, miss. I really appreciate when I see that the students appreciate me. And I would love also if you would share the video with as many students as you can so they too can benefit, right? If you have not yet subscribed, please do so and click that bell so you'll be notified when new videos come out. And if you check our catalog and you don't see a particular video that you're looking for, a topic that's really stressing you out and you need some help, you need some clarification, just let me know what that topic is. I'll do a video for you. So my scholars, take care. I'll see you in the next video.